Melting point, boiling point, and electrode potential. Now we will discuss the physical property of group 2. Firstly, atomic and ionic radii. The size of the group 2 element is large but smaller than the size of the element of group 2 due to the higher nuclear charge. The atomic and ionic size increase down the group. The melting point and boiling point of group 2 elements are low but higher the alkali metals. This is due to the smaller size of atom which fit tightly into crystal lattice. The ionization energy, due to the large size of these, they show low ionization energy decrease down the group as the size increase compared to alkali metal. Ionization energy of group 2 is still high due to their comparatively small size. Tendency to form ion in positive positive oxidation state. Alkaline metal behave as a bivalent. First, ionization energy of alkaline metal is higher than the alkali metal, but the second ionization energy of alkaline metal is lower than the alkali metal. From ionization energy, it appears that alkali earth metal would have H ion rather than two positive ion, but they form two positive ion, Mg, that is Mg2 positive, Ca2 positive. This is due to the following reason. Plus 2 ion have stable noble configuration. In solution state, plus 2 ion are small and hence undergo extensive hydration. This large amount of hydration energy is more than required of compensate for the second ionization energy required for the formation of two positive ion. Moreover, two positive show high lattice energy in a solid state. This high lattice energy compensate for the ionization energy and provide the greater stability. Now we will discuss the basic nature of hydroxide. The alkaline earth metal react with water to form hydroxide. The reaction is slow as compared to alkali metals. Hydroxide are basic in nature, and the basic nature of hydroxide increase down the group. Reason behind this, on moving down the group, ionization energy of the alkaline earth metal decreases. The MOH bond become weak and OH negative ion will easily released. So basic character of hydroxide increase down the group. Now we will discuss flame coloration. Group 2 elements also give flame coloration due to low ionization energy. Calcium show brick red color, strontium show crimson red, and barium show grassy green. On heating, the electron of the valence shell get excited to valence shell level. The excited state are unstable and the electron get back to the government state of emitting heat energy in the form of radiation which fall in the visible region. This give characteristic color to the flame. Now the question arises, why beryllium and magnesium do not show coloration to the flame? Size of barium and magnesium are very small in the group, therefore they have high ionization energy. The heat provided by flame is not enough to excite the electron, hence no color imparted to the flame. Nature of metal bonding. In alkyl halide, the earth metal 2 electrons per atom take part in metallic bonding. Moreover, the atom are small and hence closely packed as compared to alkali metals. That's why alkaline earth metals are higher, denser, and high melting point and boiling point. Heat higher heat of atomization. The metallic bond strength down the group as the size of atom increase. Now we will discuss diagonal relationship of beryllium and with the hydrogen. Beryllium show diagonal relationship with aluminium because both have similar charge in size ratio, similar electronegative, similar enthalpy of vaporization, similar polarizing power. The similarity in these various property are shown. Both form covalent compound. Both become passive on treated with concentrated HNO3. Both are weakly electropositive in nature. BeCl2 and Al2Cl6 are bridged polymeric structure. Carbide of boron and aluminium liberate methane in H2O. Beryllium and aluminium form complex. Silent feature of hydride of S block. The element of S block group 1 and group 2 are electropositive. Hence these all are form ionic hydride with hydrogen. The hydrides are ionic white crystalline solid. The ionic nature increase down the group. The hydride are very small and stable, hence react with water, release H2. Hydrides are strong reducing agent. They reduce organic acid to alcohol. These hydrides can be used to prepare complex structure of hydride and S block elements. Hydride of group 1 element LiH, NaH, etc. have NaCl type of structure. BeH2 and MgH2 are polymeric solid. These are the electron deficient compound. When one beryllium atom is bonded to a 4 hydrogen and banana bond is special feature of this compound. When 3 atoms are bound by 2 electrons, these bond is called 2C2E electron. Anomalous behavior of beryllium. Beryllium differ with other member of the same family. It is due to the following reason. Beryllium has small atomic and ionic radii. It show high ionization enthalpy. It show high electronegativity. It show high charge density. And the absence of d orbital. Beryllium differs from other member of its group in the following way. The beryllium is harder and denser than the remaining member of the beryllium and has a small and fit compactly in crystal lattice. It is very high melting point. The ionization energy of beryllium is very high due to the small size. Beryllium form covalent compound while other member form uric compound. Beryllium oxide is atmospheric while other oxide of other member are basic in nature. Complexation tendency of S block. The tendency to form coordination compound lack in the both alkali metal and alkaline metals. This is because of their large size, low charge and absence of vacant orbital of energy level in ground or excited state. However, alkali metal form complexes with chelating group like salicylaldehyde. Such ligands are strongly complexing agent because these are multidentate and form ring compound with metal ion. For example, sodium ion form salicylaldehyde complex are as follows. Sodium ion attain a coordination number of 4. However, potassium, rubidium and cesium can form coordination number with salicyl aldehyde as shown in the figure. Similarly, group 2 element have small size and have higher charge. Thus, these should be better at complexing as compared to the group 1. BeF2 coordinate with the 2F ion. to form a tetrahedral complex. The most important complex in this planet is chlorophyll, formed by magnesium. All life depends ultimately on chlorophyll and photosynthesis. Magnesium site at the center of the flat heterocyanide ring organic ring system called porphyrin. Here, four nitrogen atoms are bonded to magnesium EDTA. Ethyl diamine tetraacetate acid is hexadentate ligand which has 4 oxygen and 2 nitrogen donor site. EDTA complex with calcium 2 positive and magnesium 2 positive. This process is called determination of hardness of the water. Complexes of alkali metal ion bicyclic polyethers. Crown ethers are macrocyclic polyethers synthesized by C.P. Pedersen for the first time. These are the called crown ethers because the atom form crown shaped ring. Crown ethers bind the cation strongly selective. For example, KMNO3 dissolve in benzene in the presence of 18 crown 6. From various experiments, it has been found that close fit is possible while the cavity size when the cavity size of polyether matches with the size of anion. Now we will discuss cryptates. Cryptates are the polycyclic ligands that contains other donor atom like nitrogen, sulfur, phosphorus, etc. in addition of oxygen. These are one more selective, more crown ether. The structure of one such as cryptate. Sodium form the compound Na222 cryptate. Na in ethylamine solution. It is yellow color, golden yellow dimagnetic solid, stable up to -10 degrees Celsius. The interesting feature of this compound is that it contains solidide ion Na negative. The cryptate ligand shield the Na positive ion and prevent it from untightening with Na negative ion. Difference between crown ether and cryptate. They differ from each other in the following ways. Crown ether are monocyclic polyether where cryptates are polycyclic. Crown ethers have only one oxygen as donor atom while cryptates has nitrogen, sulfur, phosphorus in addition to oxygen as donor atom. Functions of S block elements. Role of potassium and sodium. A required level of sodium and potassium level is maintained in the extracircular and intracellular field through sodium pump. These result in the development of electrical potential across the cell membrane. It is responsible for the functioning of the nerve and the muscle cell. Role of Mg positive and Ca2 positive. Mg positive ion are present in chlorophyll, which is responsible for the life on earth. Mg2 positive ion activate phosphate transfer enzyme which help in the releasing energy of animal bodies. Mg2 positive ions are required for the carbohydrate metabolism. Calcium and magnesium ions are responsible for the transmission of nerve impulse and contraction of muscles. Calcium ion help in the formation of teeth and bones. Calcium ions help in the blood clotting. Calcium ion maintain the regular beating of the heart. It's over for our S block elements. We will discuss next chapter in our next lecture. Thank you. Have a nice day.